Solve problem on outside cylinder uncoupled locomotive. Given question, the following data refer to an outside cylinder uncoupled locomotive. Mass of rotating parts per cylinder 350 kg, mass of reciprocating parts per cylinder 300 kg, angle between cranks 90 degree, crank radius 0.3 meter, cylinder centers 1.8 meter, radius of balance masses 0.8 meter, wheel centers 1.5 meter. If whole of the rotating and two-thirds of the reciprocating parts are to be balanced in the planes of the driving wheels, find first magnitude and angular position of balancing masses. Second, speed in km per hour at which the wheel will be lifted off the rails when the load on each driving wheel is 30 kN and the diameter of the tread driving wheels is 1.8 meter. And third, swaying couple at speed found in second plane.
This is the question for outside cylinder uncoupled locomotive. Let us understand the given data and we will draw the diagram for the position of planes. Mass of rotating parts per cylinder. M1 is equal to 350 kg. Mass of reciprocating parts per cylinder. M is equal to 300 kg. Angle between cranks is equal to 90 degree. So we know that in locomotive the cranks are set at 90 degree apart and it is mentioned in question. Then the crank radius 0.3 meter and cylinder center is equal to 1.8 meter. Now these cranks are set at this piston cylinder arrangement. Now this is the outside cylinder uncoupled locomotive. That means we have to show cylinder at the outside and the wheels at inside. So we will show here. Now these two cylinders and wheels rotate in the different planes. So we will mention here the planes A, B, C and D. So I will mention here A, B, C and D. So these are the four planes. Now because of outside cylinder, this is cylinder 1 C1 and this is cylinder 2 C2. Now here cylinder center, that is the distance in between these two cylinders, is given 1.8 meter. So we have to show this. So I will mention here 1.8 meter. Now the crank radius 0.3 meter. So we have to show this crank radius for this cylinder 1 and cylinder 2. So we have to draw this vertical line in proportion to this 0.3 meter. So I will mention here, it is given 0.3 meter and here also 0.3 meter. Then radius of the balancing mass 0.8 meter. So we know that the balancing mass are provided on the wheels. So we have to mention this radius of balancing mass for these wheels. So here at the inside both are the wheels. So we have to show here, that is these are the wheels, that is W and W. So radius is mentioned 0.8 meter. So we will mention here 0.8 meter and 0.8 meter. So these vertical lines we have to draw with proportion to this 0.8 meter. Now the wheel center 1.5 meter. So distance in between these two wheels is also mentioned 1.5 meter. Now we have to find out this both side distance, that is the distance in between the cylinder and wheels on both the sides. So here that equal distance we have to manage. So how to calculate 1.8 minus 1.5, that is 0.3 and 0.3 divided by 2, that is 0.15 meter. So here we have to mention this. Now it is also given that 2 by 3 of reciprocating mass is to be balanced and whole rotating mass is to be balanced. So here at these two cylinders, that is for cylinder 1 and cylinder 2, reciprocating mass and rotating mass is given. Now portion of the reciprocating mass is to be balanced is 2 by 3. So what is the total mass is to be balanced per cylinder? So we have to add this reciprocating as well as rotating mass, but we have to consider 2 by 3 portion of this reciprocating mass. So total mass per cylinder is to be balanced. We will use here notation empty. Now if we observe the diagram, at plane A here will be the mass A and at plane D here will be the mass MD. So I will mention here MA and here MD. Now this MA and MD we have to calculate, that is 2 by 3 into 300 plus 350. So which is equal to 550 kilogram. So this mass is known, that is 550 kilogram and 550 kilogram. Now what is the balancing mass at these wheels? So that is unknown and not mentioned in the question. So we have to find out this balancing mass at wheel B, that is MB, and balancing mass at wheel C, that is MC. So these two terms we have to find out. Now we will prepare a table with reference to this diagram. So first column is for plane. There are 4 planes A, B, C and D. Next for mass in kilogram. So at plane A, that is mass at the cylinder, we have calculated 550 kilogram. Then for balancing mass at this wheel, it is unknown and we will mention as it is MB. Then balancing mass at C, it is unknown, so we will mention as a MC. And then the mass at cylinder C2, it is 550 kilogram. Then we will move for the radius of the rotation. So radius of rotation in meters. So at plane A it is 0.3, at B it is 0.8, then at C it is 0.8 and then again it is 0.3. Then we will find out the centrifugal force. So centrifugal force is mr omega square. But here omega, that is the angular velocity, is constant for all these rotating masses, and we will refer here formula F is equal to m into r. So we will take here 550 into 0.3, that is 165. Then here 0.8 mb. And next 0.8 mc, and again it is 165. Now we will move for the next, that is the distance of the different planes from the reference plane. Now if we observe here, the mass mb and mc is unknown. So we have to select any one plane in between B and C. So if I select this plane B as a reference plane, so we have to mention here this plane as a reference plane. Then we will find out the distance. So here if we observe, plane A is at the left hand side of the reference plane and other planes are on the right hand side. So how to measure this distance? So on the left hand side we have to measure the distance in negative. So for plane A, the distance from the reference plane, that is L, is minus 0.15. Then for the plane B itself is a reference plane, so L is equal to 0. For plane C, it is the distance is plus 1.5, and for plane D 1.5 plus 0.15, that is 1.65. So we have to mention this. Now we will calculate the couple. So couple is force multiplied by this distance of the reference plane. So if we calculate this, we will get minus 24.75. Next is 0, and if we calculate this, then we have to calculate 1.5 into 0.8 into MC. That is 1.2 MC, and last one is 272.25. Now we will find out the angular position theta. So if we observe, the cranks at these two cylinders are 90 degree apart. So if we consider the crank for this cylinder 1 is at 0 degree, then crank for the cylinder 2 is 0 plus 90, that is at 90 degree. And now the position of this balancing mass for these wheels is unknown. So I will write here as a theta B and theta C. if we observe this couple, only one term is unknown and for first two terms are unknown. So we will first draw the couple polygon with some suitable scale. So scale 1 centimeter is equal to 11 kilogram meter square. Now if we observe the mass placed at A is at 0 degree and the mass placed at D is 90 degree. So we will draw here one diagram, that is mass at A at 0 degree and mass at D is at 90 degree. Now if we observe, couple value is minus 24.75. So as per this scale we have to refer here scale 2.25 centimeter. Now because of the minus sign we have to draw one horizontal line at 0 degree with left hand side direction. So I will take here one reference point as a point O and draw one horizontal line as a 2.25 centimeter and show here one direction towards the left hand side. Now again at plane D, if we observe, it is at 90 degree. So here for 272.25 couple value we have to take scale 24.75 centimeter. So for this horizontal line we will draw here one vertical line at 90 degree, that is perpendicular line. So we will consider here 24.75 and we will draw this vertical line and we will show arrow also, and next point will be small point D. Now again if we observe, we have to show here the magnitude. So what is the magnitude for this? That is 24.75. And what is the magnitude for this vertical line? That is 272.25. Now we will join these 2 points, that is D and O. We will show here the direction also, because this couple polygon should be closed. So direction is in the downward direction. And what is its value? So value is 1.2 mc. If we measure this distance D to O, then it is equal to 25 centimeter. So we will multiply with scale 11 kilogram meter square. So 25 into 11, which is equal to 1.2 mc. So mc, that is the mass at C, is equal to 229.16 kilogram. Now how to measure the angle? So I will transfer this line as it is in this diagram. So here this is the direction, that is in the downward direction we have to show, and we have to measure the angle from this 0 degree. So if I measure this angle, then it is equal to 275 degree. So theta C is equal to 275 degree. Now we will move to draw force polygon to find out the unknown terms theta B and MP. So we will consider some suitable scale. 1 centimeter is equal to 10 kilogram meter. So for this force polygon, first is plane A, which is at 0 degree and scale is plus 165. So as per this scale, we have to consider here 16.5 centimeter. So I will consider one reference point as a point O, and because of positive sign, we will draw one line towards the right hand side direction, and magnitude 16.5 centimeter. So this will be the point A. Now next we will consider here this for plane D, which is at 90 degree, and again it is 165 kilogram meter. So as per this scale, we have to consider here 16.5 centimeter. So again I will draw here one vertical line which is at 16.5 centimeter. Now this point is for plane D. So I will take here the letter D. Now next term is for plane C. We have calculated this 0.8 into MC, that is 183.32. So as per this scale, we have to take which is equal to 18.33 centimeter. Now angle theta C is 275 degree. So we can transfer this angle from this couple polygon, and if I transfer this angle from D, then we have to take here So with the help of roller we can transfer this, and it is 18.33. So we will mark here one point. Now we have to join the points. So it's a plane C. So I will mark here the small letter C. And now this first polygon should be closed. So we have to join these points O and C. So we will join this. Now we will show arrow from this point C towards O in this direction. Now we will write the magnitude. So for this point O to A, what is the magnitude? 165. Then from A to D it is again 165. Then from D to C it is 183.32, and from C to O it is 0.8 MB. So now we will write here this magnitude 0.8 MB. Now if we measure this scale from C to O, then it is 18.4 centimeter. So we will refer here with scale 1 centimeter is equal to 10 kilogram meter. So we will calculate at 0.8 MB is equal to 18.4 multiplied by 10. So MB is equal to 230 kilogram. Now how to measure the angle? So we will transfer this line C to O as it is in this diagram, and we will plot here the mass MB. Now if we measure this angle, then this angle is equal to 169 degree. So theta B is equal to 169 degree. Now if we refer this mass at B as well as mass at C, then it is 229.16 and 230. So we will refer here this mass at B, that is MB, which is equal to MC, which is equal to 230 kilogram. Now we will calculate balancing mass for reciprocating parts, that is MB. So here is the formula: mass of reciprocating parts multiplied by C. So C is the fraction of the reciprocating parts which is to be balanced, and it is equal to 2 by 3 divided by total mass per cylinder to be balanced multiplied by balancing mass at V. So we can also rewrite this as mass of reciprocating parts, notation is M multiplied by C divided by total mass per cylinder is to be balanced, that is MT multiplied by balancing mass at wheel. So balancing mass at wheel, that is MB or MC. So we can take any one term. So we will take here as a MB. So this is the formula to calculate the balancing mass for the reciprocating parts MB. Now when we put the values, then we will get the answer 83.63 kilogram. Now to avoid the lifting of locomotive, so we have formula, that is we have to manage this angular velocity omega, and it is equal to under root of P divided by MB RB. Now if we observe the diagram for the wheel, then P is the total load for this wheel as well as locomotive, which will act at the center of wheel, and it will act in the downward direction. So this value of P is mentioned in the question, that is 30 kilonewton. So we will convert it into standard unit, that is 30 into 10 raised to 3 Newton divided by MB RB. So this MB, that is equal to 83.63, and this RB. So RB is the radius of the balancing mass for this wheel. So value of RB at wheel is given 0.8 meter. So we have to calculate this, and answer is 21.17 rad per second. Now from this omega we will calculate the linear velocity. So for wheel, omega is 21.70. Then the radius of wheel, capital R, is also given 0.9 meter. So we know that linear velocity V is equal to R omega. So when we calculate this, then we will get the answer 19.05 meter per second. So this is the first answer. Now we will move to the next question, swaying couple. So how to calculate swaying couple? So we have formula CS is equal to A by by root 2 1 minus c m r omega square. So A, that is the distance in between the cylinder center, and it is mentioned as 1.8. A by root 2 into 1 minus c. C is 2 by 3. 1 minus 2 by 3. M. Mass of reciprocating parts, that is 300 R. That is the radius of this crank. So it is also given, that is 0.3, and omega we have calculated. So when we calculate this, we will get the answer. Swaying couple is 15.9098 into 10 raised to 3 Newton meter.